So hello everyone, in this video we'll be solving another LeetCode problem and the problem name is best reachable tower. So you are given a 2D integer array towers where towers of I is given as xi, yi and qi, which represents the x coordinate and the y coordinate and quality factor qi of the ith tower. Now you are also given an integer array center which represents against the x and y coordinates of the center point, which is actually your location, and also you are given an integer radius. A tower is reachable if its Manhattan distance from center is less than or equal to the radius. Now among all reachable towers you need to return the coordinate of the tower with maximum quality factor, and if there is a tie then you need to return the tower with the lexicographically smallest coordinate, and if no tower is reachable then you need to return -1, -1. And then they have given the definition of Manhattan distance, that it is the distance between two cells xi, yi and xj, yj, such that the absolute difference between the x coordinate and y coordinate, you just take the sum, so you get the Manhattan distance. And then they have said what is the lexicographically smaller. So a coordinate xi, yi is lexicographically smaller than xj, yj if x of I is less than x of j, and if x coordinates are equal then y of I should be less than y of j. And this represents the absolute value of x. This is what the question is saying. So let us understand what actually question means. So you are given some towers and each towers has some x coordinate, y coordinate and some quality factor. You are also given one point center which is nothing but cx, cy, and this is your location. Now there can be many towers. Now from this center location you need to calculate the distance from all the towers, or more specifically Manhattan distance, and that Manhattan distance should be less than or equal to the given radius. Now if this condition follows, you need to return the tower with maximum quality factor, which is this q, and if few towers have equal quality factors, then you need to return the lexicographically smallest coordinate which is present. So let's say some coordinate is 1, 2 and some coordinate is 2, 2. So in this case this is lexicographically smaller. Let's say some coordinate given as 2, 3 and some coordinate is given as 2, 4. So in this x coordinates are equal, but y coordinate, this one is smaller, so this becomes the lexicographically smaller coordinate. So let us see the second example and try to look how things actually work. So yes, this is the second example and you have given the towers as 1, 3, 4, 2, 2, 4, 4, 7 and center coordinate as 0, 0. So for tower 1 we can calculate the Manhattan distance. So let me just erase this. So Manhattan distance is given as absolute difference between the x coordinate, absolute difference between the y coordinate and the summation of those. So from the center point this is 0. So 1 minus 0 plus y coordinate is 3, 3 minus 0. So this comes out to be 1 plus 3, that is 4. So tower 1's Manhattan distance from the center is 4. And then we will come on to this second tower. So tower 2. So tower 2 has Manhattan distance to be 2 minus 0 and plus 2 minus 0. So again it comes out to be 4. Now we will check the tower 3. So let me just move this a little bit. Okay, yes. So now we come to tower 3. So tower 3, so again it is 4 minus 0 and we have 4 minus 0 again, yes. So its Manhattan distance is 8. Now the radius given to us is 5. So we need to consider those towers only whose Manhattan distance is less than or equal to 5. So tower 1's Manhattan distance is less than equal to 5 and tower 2's Manhattan distance is less than equal to 5. So we will consider these two towers. So we will not consider this tower 3. So now among tower 1 and tower 2 we need to check whose quality factor is more. That tower we need to choose. So tower 1's quality factor is what? So its quality factor is this 4, and tower 2's quality factor is what? Tower 2's quality factor, it is also 4. So now there is a tie in the quality factor also. Then we need to do what? We need to compare the coordinates of both of these towers. So tower 1 has coordinates as 1, 3, and tower 2 has coordinates as 2, 2. So the lexicographically smaller coordinates we will be choosing. So among 2, 2 and 1, 3, which is lexicographically smaller? 1, 3. So our answer would be returning as 1, 3. And if you look at the output is 1, 3. So simple implementation based problem, we can just implement what the question has asked us to find out. So let us see the code, how will we do it. So yeah, this is the code. So first of all, I have declared a variable n, which will be just telling how many towers are there. Then I have created a vector v, which is nothing but pair of int comma pair of int comma int. Now why I have created? Just to make sure I store quality factor, x coordinate and y coordinate respectively in these positions, because we need to sort on the basis of quality factor. If quality factor has a tie, then on the basis of x coordinate. If x coordinate is tie, then on basis of y coordinate. So this is the order that I have followed. So I have created a vector of pair of int comma pair of int comma int, and I have declared the name as v. So I am just iterating on each and every tower. I am getting its x coordinate, towers of I, 0. I am getting its y coordinate, tower of I, 1, and I am getting its quality factor of tower of I, 2. Then these are the center coordinates cx and cy, which is nothing but center of 0 and center of 1. Now I will be calculating the Manhattan distance. So a Manhattan distance is what? Absolute difference between the coordinates and take their sum. So for the x part, we are just taking the absolute difference from the center till the current tower's x coordinate, and same with the y coordinate. From the center, we are just taking the absolute difference with the current tower's y coordinate, and we are just adding these two. And yeah, this is how we'll be getting the Manhattan distance. Then we are checking if this Manhattan distance is less than equal to radius, then push this tower into our v that we have created. Now why we are pushing? Because we know that we can have multiple towers with which will follow this condition. So in the end, we are just checking if this v has some towers or not. If it doesn't have any towers, that means there is no tower whose Manhattan distance is less than equal to radius. So simply return -1 comma -1. And if it has some towers, we need to get the tower which follows the condition which question has given. First with the highest quality factor. If high quality factor is tie, then on the basis of x coordinate. If x coordinate is tie, then on basis of y coordinate. So we are just sorting based on the comparator function, and whatever is the topmost value, we are just returning that. And what is this comparator function? So let me just show you. So yeah, this is the comparator function which takes the pair of int comma pair of int comma int, and we are just checking first on the basis of quality factor, then on basis of x coordinate, and then on basis of y coordinate. So it will first keep quality factor's value as maximum on the top. If there is a tie between the quality factor, it will make sure that least x value should be coming next. So least x value should be coming next. And if there is a tie in the x coordinate as well, then least y coordinate should be coming next. So this is just a normal comparator function. On the basis of this, we are just sorting it. After sorting, whatever is the top value, that means on the basis of maximum quality factor or x or y, just return that value. So I hope you understand this problem. Thank you for watching.